I guess
Okay, apparently I'm live. I hope we can see things. The reason why it's a little darker, Nella, is because of the glare on the board. I'm trying to prevent that. I'm hoping this will work. It's an experiment. You let me know if it's just too dark. Okay, here we go. Do you have any questions on 1, 2? I can only spend about 5 minutes on it. I got so much to show you today. 29.
I think it's. I'm pretty sure.
Yeah, you'll want to do this.
I got it done. I just.
Okay, we're taking the absolute of x, translation 2 units to the right, followed by a horizontal stretch by a factor of 2. That can be kind of rough, especially when it's followed by anything horizontal. It can be kind of rough. So number 29, the function is f of x equals absolute x. And we're going to do it one transformation at a time. Our final one is supposed to be called, well, it doesn't say what it is. Oh, yes, it does. Up in the instructions up above, it says your final one should be called G. So for my intermediate one, I'm going to call it H. Okay? Everybody understand what I'm doing? And the first thing I got to do is go 2 units to the right. So H of x is going to be 2 units to the right, looks like this. X minus 2. Do you agree? Mm-hmm. Okay, that's H. Now to H, I will apply the next one, which is a horizontal stretch by a factor of 2. A horizontal stretch by a factor of 2 on H is going to be G will equal G of x. G of x will equal H of, it's horizontal, which takes place inside. Stretch of 2 means opposite of what you think, which in this case is starts with an R. Reciprocal of 2, which is 1/2. That's what G is going to be to make the horizontal stretch of 2. Are you with me? Okay. That means that G, when we apply it to the H we just came up with, that means that G is going to be, every x is going to get replaced with 1/2 an x. That's it. And I think, nope, that's correct. Okay. We okay with this or not? One more is all I can take. What do we got? Anybody want to talk about one more? How many of you submitted it with 90% or better? Awesome. How many of you that did not raise your hand have it on paper and you think it's 90% or better? Awesome. That leaves a few hands left undone. I hope you guys get it done over the weekend. Do I have Akira in this class? Okay, and did you get a book and a calculator from me?
Oh, no.
You have your own calculator? I just didn't get a book number to calculator because I don't know what happened that first time. So, can you give me a book number?
No, it's number 65.
65 or 165?
Just 60. Yeah, or the one showing.
Can we go over 15?
Yep, but that's the last one. So if you still have questions after that, you'll have to wait till Monday and I'll help you out then. What'd you say, 15?
Yeah.
Okay, above that, the instructions are write a function g whose graph represents the indicated transformation of f. Use a graphing calculator to check your answer. Okay, so number 15, this is not a parent function, but they want us to reflect it in the y-axis. So we write down the function we're working on, which is -3 plus absolute x minus 11. And that's f. And g must do this. In a general way, this is our general interpretation of it. G must be f of -x. Right? Because that'll reflect it in the y. It's horizontal, or reflection in the y-axis is horizontal, so the negative belongs inside. And what this tells us is that when I actually write g pertaining to this function, every x in it will be replaced with -x, because that's what's in the parentheses. Yeah? So g of x is going to be -3 plus absolute -x minus 11. And because this is -x, we have to apply that Cute little property we learned yesterday. Which means we got to factor out a negative in it. We got more work to do on this, in other words. Negative, and then it will be x plus 11, because I factored a negative out of that as well. Yeah? You clear? And then the absolute value of this negative 1 is just 1, so I can throw it away. So it ends up being negative 3 plus the absolute value of x plus 11 for an answer.
Is that 15?
Yes.
Yeah, no, mine, I had to do -3 plus absolute value negative x.
Okay, to get the correct answer in the thing.
Yeah, I have the negative.
Those guys they teach you this thing and then they don't allow you to use it. So if to get it right in Big Ideas Math, you have to type this, that's fine. I would prefer this on a test. I probably won't mark this wrong, but you'll put me in a bad mood for the rest of your test. You're liable to get dinged. Use this skill. It's important.
Wait, so
They teach it to you, you should have to use it.
So
But
if it's a negative, you absolute value the 1 and then.
you absolutely value the negative 1, throw it away because it's just a 1 now. And write down, but don't forget to factor that negative out of this back term as well. It's really x plus 11. Okay. Did you have a question? Okay. All right. I'm afraid I don't have time for any more because this is Friday and I got, like I said, I got a lot to tell you. So we're moving on to section 1.3. So please move to page 22. And for Nella's sake, keep in mind that I've got to stay on this board, so it's going to be a lot of erasing. Try to stay with me. Okay, here we go. On page 22, the two objectives are write equations of linear functions using points and slopes. That should be a reminder. You may not remember how to do it in detail right now, but you should with not too much reminding at this level of your math.
is this easier than yesterday's lesson?
No. The concepts may be easier. Making your calculator work for you is going to be tougher. You're going to want to take notes when we get to the calculator part. So we're going to write, this will be pencil paper right here. We're going to write equations of lines giving points and slopes. And the second part is we're going to find lines of best fit with your calculator. And it is complex. So I'm not going to spend a huge amount of time on this first part. There's two problems. They're interesting. And hopefully you'll remember some things. First of all, whenever the problem instructions say write the equation of a line, this is what has to come into your mind. This is called the point-slope version of a line. Point-slope. Point-slope either goes to standard form, which we won't do today, so I'm not even going to put it down. Or once you get it in point-slope, they may ask you to convert it to slope-intercept. That we will use. Yep. And slope-intercept form is y equals mx plus b. In other words, you're going to have to start by writing this, then you're going to have to do some math on this until it turns into this. I'll show you how. There's only two moves. It's not hard. By the way, in this form right here, that's called point-slope. That's your start point. Point-slope, the reason it's called that is because to write it, you need a point, which is x1, y1. Please notice that x1 is the last thing you write, y1 is one you write. But that's the reverse of how the point is written. You have to go to the back end of the point to get this number, and you have to go to the front end of the point to get this number. And this is slope. There's lots of ways to find slope. And by the way, this x and this y remain x and y as variables so that those two thingies can generate all the other points on the line. So they have to remain variables. Okay? So with that in mind, here we go. Example 1. If you look at it with me on page 22, you have to have your eyes on the graph.
What standard?
Standard looks like this, but we'll be using it today. It looks like this. Where A, B, and C are all non-fractions, and A, B, and C are relatively prime, and A is positive. That's why we're not doing it today. It's a whole section on its own. Okay, will you look with me at example 1? You gotta have your eyes on that graph. Page 22. Y'all there?
Yep.
Okay. It says, the graph that your eyeballs are glued to says the graph shows the distance asteroid 2012 DA14. None of those numbers have anything to do with the problem. It's just the name of the asteroid. It has to do with how far it travels in X seconds. Write an equation of the line and interpret the slope. Then, the asteroid came with 17,200 miles. Within 17,200 miles of Earth in February 2013. About how long does it take the that distance? Okay. Do any of you have any idea how far the moon is from the Earth on average?
200,000.
Very, very good guess. It's very, very close. About 240,000. It's great. Can you see how much smaller 17,200 is?
That's scary.
That is scary. That came way closer to Earth than the moon is. That's scary. Yeah. Okay. So, looking at the graph, they have the point there that is the point 524. Clearly outlined on the graph for you. But notice what each of those axes represent. We've got time in seconds, and we've got distance in miles. So keep in mind what those numbers on the X and Y axis represent. Now, the first thing that they ask us to do is, notice the word write. Write an equation. Okay, so we are going to use this. It says write an equation. This is where we start. So for this one, we're going to write y minus, what's one y coordinate that you know? 24. Equals, what's the slope? And that's what everybody does. You may be able to figure it out. Don't tell me yet. I'm gonna leave a gap for it and write x minus 5. Good. That's the x coordinate. That's the y coordinate. We subtracted them both because they were both positive. If one of them was negative, by the way, then the result in here would be positive. This means the opposite of x1 and y1, not necessarily a negative number. The opposite of it. But these were both positive numbers in the point, so they are going to be negatives in the writing here. How can we find the slope of this one? Go ahead. Count, rise, over, run. How far do you have to rise and how far do you have to run from one point to another?
24 over 5.
No, it goes by Tuesday names, so you have to go by what the chart is.
Yes, but look at the point. 20. I realize that the axes are numbered fine, but you're actually at the point 524. How far do you have to rise and then run to arrive there? 24 over 5. 24 over 5. And I heard that before, and that was excellent. I know. You said it. It's great. I just wanted to convince everybody else. 24 over 5 is the slope. That's practically 5. Do you agree? If you wanted to write a decimal here, that would be fine, rather than have to deal with the fraction. But what we're going to do now that we've written this, we've got the x1 filled in, we got the y1 filled in, and we figured the slope by rise over running. Got that? Now we're going to convert this to this form. Okay? So I'm going to have, the first thing I'm going to do is get rid of the parentheses, because this doesn't have any parentheses in it. So I'm going to distribute. That's your first move. Is it okay if I call this? No, it's okay. I'll go ahead and distribute. 24/5 x. Now think about this, because you guys are sharp math people. When you multiply this times this, the 5s are going to cancel. Right? Okay.
Oh.
Then if you add 24, you get because negative 24 plus 24 is 0.
Wow.
Besides that, this number at the end of this right here is where it hits the y-axis. Where does that line hit the y-axis? That's 0, which is what you expect. Just verify that. Okay, so here's what we were asked to do. Write the equation of a line and interpret the slope. We wrote the equation of the line. That's all we've done so far. Interpret the slope. Remember I told you this was practically 5. It's actually about 4.8. 4.8 what?
Miles per second.
Miles per second. Because this was miles, if you look at the y-axis, that was y over x, remember? Rise over run is y over x. Miles, that's looking at the axis per second because the x-axis is in seconds.
That's really
Yeah, 4.8 miles per second is from here to Rexburg in 1 second. That asteroid is hauling bananas. It's moving. Okay? If it hit the Earth at that speed, oh my goodness, would we be devastated? Okay, so that's the interpretation of the slope. You can either say 24/5 miles per second, or you can actually make it something people understand by converting to a decimal. 4.8 miles per second, practically 5 miles a second. Either way is fine. And the next one says the asteroid came within this amount of miles, 17,200, on 2013. About how long does it take the asteroid to travel that distance? Which one of the variables is time? X or Y? X. They're asking how long. They're asking you to find X. What are they giving you?
The Y.
A distance, Y. So we have 17,200 for Y. We substituted in our equation. Equals 24/5 X. How do you solve for X?
You divide.
You divide by 24/5 or multiply by 5/24, or divide by 4.8. It's easier to punch your calculator if you use 4.8, right? That's another reason why the decimal's nice. So take 17,200 divided by 4.8. What do you get?
3,583.
Wow.
What is that measured in? What's the units on this?
Second.
Seconds. Yeah, because we were looking for time, and time in this whole scenario is measured in seconds. Do you have a feel in your mind for about how long or about how big 3,600 seconds is? Most people don't. Let's convert it to something we can understand. How do you convert that many seconds to hours? Divide it by 60 and then divide it by 60. Because if you divide it by 60, it'll give you minutes. You divide that by 60, it'll give you hours. So in other words, that's about an hour. 3,600 over 3,600. Because 60 times 60 is 3,600, right?
It's like 59.
Okay, so about an hour. This could never, ever happen in any physics. But what that means in the context is, if this is Earth, and this is the path of the asteroid coming really, really close, that if at its closest point, it came to an abrupt stop, huge amount of brakes, and headed to us, it would take an hour to get here. That can't happen. Asteroids don't behave that way. The gravity of the Earth may have bent its path a bit, and maybe it ended up going like that because of the gravity. But it can't just stop at the closest point and go, okay, I'm gonna head to Earth and kill him. That's not gonna happen. But that's what we just discovered is that's how long it would take to cover that shortest distance that it can. That's all. Okay. Okay, moving on. I got lots to do. So go to example 2.
So wait, what would the answer be like? What would?
The answer would be about an hour. Yeah. And if you do Big Ideas Math and submit it that way, generally it'll have a box, it'll have units over there, it'll give you an idea how much to convert it to. Okay? If it says seconds, then you write this in there. It'll usually say seconds to the nearest second, and then in that case you would write 3583. So usually at the end of the box, it'll tell you what units they want it in. I just wanted to get it in context for this problem so that you could understand about how long was something you can imagine. Okay, example 2. Oh, by the way, Cassidy, this is also part of the answer. They wanted you to find this, interpret the slope. That would be part of the answer. We all did that verbally. The interpretation of the slope is 4.8 miles per second. This is how fast the thing's going. And this is the other answer. So there would be actually 3 answers on this. Well, this may have been converted to an hour. It depends on the units they want. Okay, here's something a little closer to home, literally and figuratively. We're talking about a committee that has got to decide where to have the prom that will cost them the least amount of money. So here's our deal. 2 prom venues. What's a venue? Yeah, it's a place.
Like a center.
Yeah, where everybody's going to come. Yep. 2 prom venues charge a rental fee plus a fee per student. The table shows the total costs for different numbers of students at Lakeside Inn. So the table that's just to the left here, where your eyes should be focused at this point. This is Lakeside Inn, that's the venue, and this is what they sent the committee to give them a price range of things that's going on. So they sent them a table of stuff. Total cost, Y in dollars, for X students at Sunview Resort. Sunview Resort sent them an equation. And it's all dependent on how many kids come to the prom, how much you actually have to pay. And this committee's got to figure out which one's going to be cheapest. You are the committee. Yes, the doer of this problem. Which venue charges less per student? That's one question. And how many students must attend for the total costs to be the same? See, what's going on is they're going to say, you might call Lakeside Inn, and without giving you the table, and the receptionist or whatever just says, yeah, we charge $200 just to reserve the place, and then for every kid who walks through the door, we charge $6. That would be an upfront charge, and then a cost per student. And the more students come, the more it's going to cost you to go to Lakeside. You with me? Okay. So in the table, I want you to study that for a minute or two. In the table, I want you to see if you can tell me what their cost is per student.
10.
And how do you know that?
Well, in the equation it says 10x.
Oh, I'm not looking at the equation. The equation belongs to the other one, Sunview. I'm looking at Lakeside's table. Look only at Lakeside's table and tell me what you believe the cost per student is. How can you figure that out?
You just divided it.
Divide what?
1,500 divided by 100, so it's 15.
$300.
Okay, that 1,500 also includes the upfront cost, which we don't know yet.
$300.
Did you understand that?
$300.
$300 for 25 kids. Do you understand where that's coming from? Because that's correct. I just want to know if you understand where she's getting that from. Okay, look at the left side. It went from, for 100 students, it's 1,500. For 125 students, it's 1,800. So for an additional 25 students, it was an additional $300. So how much is it per student? 12. So it's $12 per student. You understand this or not? Here's what I want you to notice: the words that I've said, and you said it too. Some of the numbers were a little bit wrong, but it's okay. Everybody kept saying this many dollars per student. The operative word in that phrase is per. Per student is a divide sign. So think about this in the algebra that you've learned so far that you can't seem to apply to a real situation. Think about this with me. 1,800 minus 1,500. Isn't that something you did? Or perhaps you started at 1,500 and you said, how far have I got to go to 1,800? That's still a difference between the two. So what you did first is figured out, well, one of the things you did anyway, was figured out how many more dollars it took. That was 1,800 minus 1,500. And then you said that difference, that $300 difference, paid for 25 more students. How do you get the 25? By taking 125 and subtracting 100. Isn't that what you kind of did in your head? People, this is a slope. It's y minus y over the same x minus x. Do you remember figuring? I didn't show you that here. This is another thing you have to remember from Algebra 1. Slope is always the difference of the y's over the difference of the x's in the same order. That is the slope of a line. So in the context of this problem, by figuring out cost per student, you have come up with a slope. And the slope is 12. Okay, so it's going to cost us $12 per student. Now, think about that same table and see if you can tell me, what do you believe the upfront cost is? How many?
$300.
Okay, you think it's 300. You said it first, so you tell me, how do you get 300?
You know that it's $300 for 25 students, and 3 times 4 is what you get 100. Like 4 is what you get 100. So 3 times 4 is 1,200. 1,500 minus 1,200 is 300.
Okay, the arithmetic's perfect. Did you understand what she was doing? For 100 students to attend, if you just paid the student cost, would be $1,200. But 100 students cost you $1,500. which means your upfront cost is the difference. Can you find your volume control? Okay, no, that's fine, that's fine. Is there anyone who doesn't understand where that 300 came from? That's what we call the beginning amount. That's what you gotta pay before anybody even enters the door. That, folks, is the B part of this line. This is where things start. Because if it crosses the y-axis at B, that means if time or the number of students entering is 0, wherever it hits this line is the beginning amount. And in our case, it's 300. So guess what, folks? We have an equation for a line at Lakeside. It is y, the cost, total cost, is equal to 12x, x being the number of guests, plus the initial $300 up front. Do you see that? We now have an equation for Lakeside. They gave us an equation for Sunview. Now that they're both in the same form, we can compare. So the question asked, which venue charges less per student?
Lakeside.
No,
Wait,
Sunview.
Sunview.
Look at Sunview's equation. What do they charge per student? 10. That's the slope for them. Okay? But notice they charge more up front, which means eventually they're going to cross. One will balance out the edge of the other eventually. Because if you charge less per student but more up front, compared to more per student but less up front, eventually they're going to be the same price. Does that make sense to you? Okay, and that's the next thing. How many students have you got to attend to have their cost be the same? Well, this is the cost for Lakeview. This is the cost, or Lakeview, I think it is. And this one's the cost for Sunview. I don't know if they're both views, but you know what I'm talking about. Lake and Sun, okay? There's 10x plus 600. When will this cost equal this cost? And the answer is when this expression equals this expression. Yeah, exactly. Set them equal. 12x plus 300. When will that amount of money equal 10x plus 600? And then when I say when, I mean how many students, that's what x is. So we do the arithmetic. Well, algebra. 10 from 12 is 2. 300 from 600 is 300. X equals 150 kids. If you have exactly 150 kids walk through the door, doesn't matter where you go. Where would you choose if you had 200 kids come to the prom? Why?
Cheaper.
Cost per student is less there. It overcomes this after 150. If you're only going to have 80 kids come, you want to pay more per student because your upfront cost is less. Do you see how to interpret this? This is very, very typical of questions on the ISAT test, where they give you two things to make comparisons, but they give them to you in different forms. That first one is called numerical, the tabular, the table. It's called the numerical form, and the Sunview was in equation form, and you got to somehow be able to get the two together to compare them. This is the process. Everybody good? Okay, moving on. Here's where your calculator comes in. You've got to get that calculator out and try to stay with me. And if you want, I can forward this video to everyone so that you can see this. No, I'm going to have to move this around so she can see it and you can see it too. Well, it's already videoing. It's videoed everything we've done so far, but I'm going to show you how to operate your calculator. It's very complex and you will likely not remember the sequence of events, but I'll send you the video and you can look at it again. Yes. Of death. Right.
That's how I feel right now.
You cannot leave your calculator. Who else needs one?
You didn't
Give
need
them
the
to you.
graphic calculator.
They didn't give them to you to be left alone at home.
Had to be a graphing calculator at first. I thought I was
Those
gonna.
calculators are going to save your life.
This thing will change your life. I want you to. I want these back. If I don't get them, if you walk out of this room with them, we'll be sorry. Because I'll come after you and boy, will I count. You leave them here and get your own calculator back at home. I gotta get this a little bit closer. I think. Boy, that sure is a lot of glare.
We're not taking they're tricky.
That might be better. That's still bad. Hang on. plug my calculator in. We're gonna go through this process. And if you forget or you get done with it, you go, I could never do that by myself, then I'll send the video out to you and you guys can look at it this weekend and go through the process again. You can pause it and start it again, however, wherever you want. What this TV does is I'm able to plug my calculator into it and it will show you the window that results in what I do, but I'll be telling you verbally what to do. So hopefully you'll be able to follow. Except for word.
Here we go.
Hold on. Get the curlies out of this. Okay. Come on, buddy. There it goes. So this shows you my screen. She's got the cursor up here, right? Okay.
Oh, that's fancy.
Oh, whoa.
It will show you what shows up on this, but you will not be able to see the keystrokes. So try to stay with me. Now, let's get the context of the problem in our minds before we start on this. On page 24, example 3 says, the table to the left, can you all see it? Kind of a lengthy table. You with me?
Yep.
The table shows the femur lengths in centimeters and heights in centimeters of several people. So both units are centimeters. Do the data show a linear relationships? That's the first question. Yes or no? If so, write the equation of the line of best fit, which your calculator will do for you, and use it to estimate the height of a person whose femur length is 35. So there's 3 things. Is it linear? Yes or no? It will be yes, but you'll see why in a minute. If so, write an equation of a line of fit. That's what the whole process I'm about to show you does. And then use what you've discovered to estimate the height of a person whose femur length is 35. We'll use what we came up with to make that estimate in just a few minutes. So here's what you do. Try to stay with me. Go to Stat, which is the 3rd key in the green row. You see it?
Yep.
This is what comes up. We wish to edit. So the first thing that's highlighted there, we hit enter to choose it. And it takes you into this screen, and it may not be like mine. Mine actually has an L1, L2, and L3. Does anyone not have an L1, L2, and L3 at the top? Anyone? Okay. Mine's got junk in it. So here's how you clear it. If you've got stuff in it, or later when you do several problems in a row, you're going to want to clear out these lists. You're going to want to go clear. When it's actually, you have to go up and highlight L1 and then clear that. You have to hit clear and enter, and it will dump that row. Do that to any other ones that have information in them, even if they're beyond this screen. So I'm going to go over a little more. There's my list 4. It's got crap in it too. I'm going to clear it just so that there's no question. I don't have anything in list 5 or list 6. And if you have lists beyond that, I think you can ignore them. I've got a whole bunch. You may not have that many. It's fine. The only lists you're going to be using for these problems are list 1 and list 2. But it's important that the others be empty so it doesn't try to access information from them. Everybody got a clear list 1 and list 2. All right. To make the calculator function properly, you will always put your X values in list 1 and your Y values in list 2. And this is how you do it. So list 1 comes from the femur length, which says X right there. And I'm going to type in 40 and hit enter. And that will dump down to the next element, which is 45. Enter. Please go carefully and don't miss something. Put them all in there.
Oh.
Enter after every one. When you get them, if you have the correct number of elements, you may not have them typed right. You have to be very careful. It should say down here, L1 of 11. I'm waiting for the 11th one, which means we put 10 in here. Use your right arrow and go over to the, and it'll take you to the top of list 2. Put your heights in there. Your lists had better be the same length. If they aren't, you've got troubles and you better go find out what the trouble is before you progress. Or proceed. Everybody okay? Everybody got the data entered? Okay. The next thing you need to do is to verify that your plot is set up, but you don't have to do this every time. We're going to do this one step, this one thing right now. We're going to do it one time, and it should be set for the rest of the year for you. It just may have been changed by whoever had your calculator last, depending on the class they were in. So most of yours will say this. So here's what I want you to do. I want you to hit the second function, the blue one, and the y equals key. Just above it. You should get this. Something like this. Maybe not exactly, but something like this. Now, second, y equals. Everybody there? Got this on your screen? Something like it? Okay. Now, what I want you to do is look in this particular number 1 and see if it says off. If it says off or on, I don't care. It should say off. Below it should have a thing that looks like this. This is called a scatter plot. It's a representation of a graph. Do you have this? Does anybody not have this? Okay, I'll come around to you in just a minute. You should also have an L1 here. Anybody not have an L1 here? You should have an L2 here. Anybody not have an L2? You should also have a box here. If you have some other shape, let me know. So yours is the only one that's off. Is that right? Everybody else have this in plot 1.
What if it says on though? No,
That's fine. It's fine if it says on. Off or on doesn't matter right now. So now get out of that. That's how you get out. Okay, so everybody has this for plot 1. Plot 2 and plot 3 don't matter at all to us. Everybody good? All right, you don't ever have to do that again. That's not part of the process here. So you put your data in. Let's pretend we're at that point. You put the data in, and then whenever you want to get back to the start menu, to the front screen, the way you do it, there should be a home button, but there isn't. It's the quit above the mode key. So you go second and quit. Take you back to the home screen. Okay. Now what we have to do, after you enter the data, you go back to your home screen, or you could go directly from there to Windows. So let me go back to stat. So let's say you were sitting right here and you just got your data entered. You're down at the bottom of this first list or the second list. You're like that. And you go, okay, what do I do next? Next big step is to fix a window. So the next button you push is this center key right here, window. You there? Should look something like this. You may have.
Whoa, mine is way different.
Oh, wait. Yeah. No, I lied. I was looking at it differently. Hold it. It's not the zoom key. The window key is next to the y equals key. That's what you should have pushed. Sorry. That was my fault. That's my fault. The window key is right next to the y equals key. You should have something like this. You may not have the same numbers I have, but it should be something like this. Yeah? Okay, now here's the reason why we have to design the window. We have to design the screen so that it will fit this size of numbers that we've put in the data list. So now we go back to the graph or the table and we look at the size of x's. What's the very smallest x in this list? And they may not be in order.
32.
132.
No, in the x list, what is it?
32.
Look again. 30. 30 is the smallest number. Do we all agree? Then you use this thing that says x minimum, means the smallest x that's going to show up. Don't choose 30. Choose something less than that. And because of the size of these numbers tend to range from like 30 to somewhere in the 40s, I'm going to let the minimum be 28. If it had gone from 30 up to 470, I would probably let the minimum x be 0. The bigger the gap in the numbers, the smaller below the smallest one you want to go. Okay, so I'm going to say choose 28. What's the biggest one?
45. 45.
50.
50.
50. It's okay. It's all right. 50. So I want to go somewhat above that. I'm going to go to 60. You generally go up higher on the high end than you did low on the low end. So I'm going to go to 60. And then look at the gap between these two numbers. This is the smallest x. This is the biggest one. That's a gap of roughly 30. This thingy right here called the X scale tells you how often it's going to put a tick mark on the X axis in your graph. You really don't want more than 15. So I would say to let the scale go by either 2s or 5s, something like that. I'm going to go by 2s. Oops, just 2, not 0.2. You could go by 5s, that'd be fine. It would just spread them out a little bit more. It would be 5 of them instead of 15 of them. 6 of them. Okay, so now we talk about the Y's. Now we got to go to our Y grouping there of numbers. What's the smallest Y one? 141? Okay, so I'm going to let it be 135. Go a little below your lowest one.
What's the SCO again?
That's how often it will put a tick mark on the x-axis. Okay, so our smallest Y is 141, so I'm going to go 135. And you don't have to do that. This is not a right or wrong answer, but you need to go below your lowest one. And then above your highest one. What's the highest one? Okay, 195. So 200 is a little close. I'm going to go 210. Now, the difference between this and this is practically 100. So I'm going to number these by 10s. So that I get roughly 10 tick marks. Never mess with the resolution. Always leave it at 1 for this class. Okay? Y'all understand how to set up the window. So you enter the data. That's a big step. You fix the window. That's a big step. Then you turn the plot on so you can see these points. So you go to Y equals. Oh my gosh, what a bunch of crap I got in there. Clear that out. To go up to your plot this time, go up to plot and hit enter. Plot 1. It should be darkened so that if you get off of there, it should be blackened like this. If you do that, it's not a big step, but it's very, very important. You won't be able to see anything. Hit the graph button now. The graph button way over on the far right top. See the points? Those are the points that correspond to an X of femur length and Y of height. Do they look to be linear? Not exactly, but really close, right? They're lumped together in a very obvious moving up trend. This is called a tight positive correlation. Positive because the slope of the line that would go through it is rising to the right. If your points were tending down this way, it would be a negative correlation. Yes.
Remember the loss right after we got done with the
Window.
yeah.
You got to go turn the plot on in the Y equals screen. So you hit Y equals and make sure that this is blackened. You get your navigation arrows up to there and you hit enter to blacken it. And then you hit graph and you should be able to see your points. Your graph is in the upper right-hand corner of the calculator. What's that? Is there anyone who has not gotten to this point? That's step 1. All of that is step 1. Enter your data.
Step 1.
Listen, yes. Enter your data. There are 3 steps. Enter your data, design a window, turn the plot on, and graph. These are your 3 steps. Now we have to tell, now that we've got it in there and we can see it and we've determined the answer to the first question, which is, yes, it's linear related. It doesn't look like somebody shot this screen with a shotgun. If that's what it looks like, then there's no linear relationship. It's very clear that these are trending in the same direction. Meaning, the longer your femur, the taller you are. Duh. Right? That's what it's saying. That's what it's saying. Okay, so the answer to the first question is yes. If so, and it was, so now we got to continue. If the answer was no, you move on to the next question.
So this whole thing was to figure out if it was wrong.
Yes. But we're going to use what we've got to this point in order to continue with the rest of it. It says, if so, and it is, write an equation of the line of best. If it were no, then the if so wouldn't apply and you can move on to the next question, right? But this one's clearly linearly related.
Did Siren come in?
Oh, she gone.
They said she would be gone today. She said she would be gone today. Okay, all right. So now the answer is yes, we move on. And what we've got to do now is make our calculator find the line that will be as close to all of these points as possible. If you had to do this by hand, you would probably drop out of this class. So thank goodness for your calculator. So if you're complaining and whining and thinking, oh, this is so hard, I can't do this, you are darn lucky you've got this tool, because I didn't. It was horrible to try to come up with a line of best fit with arithmetic. Terrible. Okay, so you're lucky. Remember that as you go through this. So to do the second step, go back to stat. There are 3 menus here. There's an edit menu, a calc menu, and a test menu. You will only be using edit to enter your data. And then we will go next, to do the next step, we will go to the calc menu. So you take your right arrow and move over, and this is what should show up. Notice that number 4 looks like mx plus b, only they use a. Don't let that bother you. It's just like our y equals mx plus b. So this is indicative of a line. Besides that, that's an abbreviation for line. This stands for a linear regression line of this form, and that's what you want. So you either go down to 4 or push the number 4. Now, at this point, you may not have the same thing I have. How many of you do not have this after hitting enter? Okay. I will come back to you in just a minute. So ignore me for just a minute. The rest of you, do the rest of you have this? Okay. It's asking you for 3 bits of information. First of all, it's saying I'm blinking right here, and what I would like you to put right here is, where can I find my x values? Calculator's asking you that. Where did we put the x's? Which we called L1, right? Notice the blue aspect of your number 1. The blue above it says list 1. So you go second function and L1, and it should type that for you. Y'all clear on that? Then you have to separate the next piece of data with a comma, which is right above the number 7. There's a dedicated key that says comma. So you have to separate them with a comma. Are you there? So type a comma. Then it's asking you, it says, okay, I got my x's now. Where's my y's? Where do we put them? L2. Guess where that is? Above your number 2. So we go second, number 2. Right? Hit a comma, because there's one more bit of information that it wants. And it's saying, okay, you told me where my x's are. You told me where my y's are. I'll fit a line for you, but when I get done fitting that line, your little slave here is telling you this. When I get done fitting the line through L1 and L2, where would you like me to put that line? Don't do this part. Don't do this part. Where we would like him to put it is right here. We would like the calculator to type its result here so that we don't have to, right? Well, that location is called Y1. So we're back to, going back to the home screen. This is where I'm at. Where am I going to find a Y1 to type in here? It's deep in the calculator. See this vars key right next to the clear key, to the left of the clear key. See it says vars? Hit that. Go over to Y vars, because this is a Y variable. That's what vars stands for, is variable. Yes, it's a function. We want it to be, lines are functions. And yes, of this list, choose Y1 to put it in. So it was vars, Y vars, function, Y1. You might want to write that down. Vars, Y vars, function, Y1. Vars, Y vars, function, choose function, Y1. Choose that. And when you do finally choose that and hit enter, each time you hit enter, it will type Y1. So this is the information your calculator has. Find me a linear regression, find your x's in list 1, find your y's in list 2, and when you're done calculating it, please put the equation in Y1 for me. And it's amazing to me how often people get here and say, I didn't do it. You've only given it the information. Enter, executes. Enter one more time. And what shows, just listen, what shows up on your home screen is reminding you it's a line where the slope is 2.6, the y-intercept is 65, and then if you have these or not, I'll help you get those. How many of you do not have these? Only one? All the rest of you have these r's? Anybody not have the r squared and the r? Raise your hand, I need to know.
Go backwards.
Oh boy.
This one's got
Yeah, that's kind of hard to do. Okay, to there.
L2, Y1.
Found in the vars key with this sequence.
Mine says freak list store.
Yeah, I know. It's not freak list, it's frequency list, but okay. Freak list. Yeah, no. Okay, so is that for those of you that had this kind of stuff in it? Did you get to here? Okay. Don't worry about anything else for a minute. Now I got to talk to the others. Can I see your calculator? Okay. If this is what shows up after you do the stat, calc, and choose LinReg, if this is what you get, this will always by default be list 1, list 2. You don't need to worry about that. But what you do need to do is tell it where to store it. It's still asking the question, where do you want me to put the result? Freak list should have nothing in it. If it has something in it, erase it. It's here in the store regression equation that we want to go to. So right here, store regression equation, that's where you got to type the Y1. Still this sequence. So you get your cursor parked right here, and then you say vars, same thing right there. Choose Y-var, go over to Y-vars, choose function by entering, choose Y1, and it put it right there. Now, instead of saying enter to execute, you have to come down to calculate. That tells it to do it. You get the same thing I got, only you don't have the R's. I'll get your R's for you in a minute.
I have the R's.
Some of you will, some of you won't. I will fix it so you have them because it's important to some of the questions in here. It's called a regression coefficient. No, correlation coefficient, yes.
Mine's not even letting me go to store.
You're sure it's the calculator's fault?
No, operator down and it won't let me.
Yikes, wow, that was close. There's where you are. Stay there for a minute. Let me go fix his. I'll come back to mine and we'll all have the same information in when we get it going. Because you're right at this point. Set this one thing down here. Now we're going to first bars, Y-bars, function, Y1. It's Y1 part right there, then you can do it. Okay? So if you have one form of the calculator or another, and you have everything in there that I showed you,
There we go.
then if you go to the Y equals screen, it will have typed the slope with an X behind it and the Y-intercept that you saw on the previous screen in equation form. That's why you wanted the Y1. So it will write the equation for you.
Mine only has the slope.
Did I do continue?
Oh, you're right. I'm stupid.
Is it because you had to arrow over?
Yeah.
Okay, let me show you how to fix it so that you can see it all on one screen. Would you rather have that or not?
Yeah.
So because without having to arrow over? It's called classic. Classic view. It's old, but
Can you just grab it to
Why
the
do I guess?
See it, okay? Okay. You want to change the classic view so you can see it all at once?
Sure.
Watch how it is. Remote. It's down past the screen, it's on the next screen. It says map print, which is what you're in, or classic. You want classic view. You choose that by hitting the and you have to like have a wraparound, so you see it all at once. I prefer that because I don't want to go over it. Wow. Map print, classic, I think it's chosen. There it is. That's right. Okay. Okay, how we doing? Here's the deal. I'm not sure that she can actually see this, so I'm going to talk as I write this. Nella, this is what I'm writing. The question asked, is it linear? The answer was yes. The next question is, if so, find a linear regression line. This is it. But for heaven's sake, don't give me all those decimals. Right, 2.6. 2.6x plus 65 will be fine for that. If the computer says round to the nearest tenth, then you would say 65, well, it's still 65 in this case. But you do round it to the things it tells you. But don't give me all this crap. I don't want it. That kind of accuracy is not necessary. Okay? All right. Now, the last question, by the way, that's step 2, is to go through, you go stat, over to calc, down to linreg, list 1, list 2, Y1, type the equation. That's step 2. Step 3 is the easiest of all, it's the shortest. And now, because step 3 asks the last question, it says, use what you found. This is what we found. Use it to estimate when or how tall someone with a femur length of 35 centimeters is. And this is really cool. First of all, go to your graph key,
Graph.
and it will show the line of best fit, and you can visually see, yeah, that looks pretty good. Okay, here's your third step. Listen, stay with me, do what I do. To find out where this line that we found has a femur length of 35. Was femur length X? Yes. Then you go second and the trace key, which is right next to the graph key. Because what you're trying to do is calculate on the graph screen. That's the calc menu, we call it. So second calc and a value. That's the first one. Hit enter. And it says down here at the bottom of the screen, X equals what? What do we want to predict when X is 35? So we go 35 and hit enter. And the Y value will tell you the height of the guy that has a 35 inch or centimeter femur. So he's about 156 centimeters tall. That's your predictive value of this line. And notice that there's a cursor flashing right there on that line at 35 centimeters. It wasn't one of the points that they gave us in the table, but we used the line that we fit through it to make a prediction. Yep, so that's the third one. So the answer is yes, it's linear. Here's our equation of regression, and when X, I don't need to write that, 35 centimeter femur implies, that's an implied sign, 156 centimeter person.
And you can send us this video tonight.
I will send it to you as soon as I have closed it. I'll send you the link as soon as I get one. Well, actually, I can't. I'm building an email list of you guys. When I get that done, and I'll get it done today, Mr. Gee's going to help me, I will send it to you then. It'll be there before you get home tonight, probably.
When do you go on vacation?
Next, I will be gone for the first day next Wednesday. Okay? We are nearly out of time. It's going to ring here any second. I would like to do example 4 with you, but I can't. So you'll have to refer back to this. You'll have 3 or 4 problems to do like this. You'll get enough practice that pretty soon you'll get good at it. You ask him anytime, wake or sleep, he knows how to do this. He's been doing this forever. So you will get good at it. So don't panic. You'll get good at it. I'll send you the video so you can follow. Okay? For those of you doing the assignment on paper, here's the assignment. Anybody doing it on paper? Here it comes. You ready to write? 1, 2. If you do not have regression coefficients, stay with me a minute. 1, 2, 3 to 9 odd, 10, 11 to 17 odd, 18, 19, 21, 26, 32. Bring me your calculator if you are not getting R values in your home screen. Like this. What? Yes. The closer this is to 1 or -1, the better the fit. This is a very tight fit. If it's 0.72 or less, we say that that's a poor fit.
Can I have your attention, please? Those involved in dual credit and health class and PE, please, 101. Meet in the cafeteria. That's those who are involved in health programs.
Okay. Next time you do a regression, you should show up.
Okay, thank you.
Okay, thank you. I need your calculator back. Whoever borrowed one. Yeah, it gets late. Together would be fine as long as it's on separate sheet. Okay? All righty, thank you. Does your diagnostic show up?
What?
Do your diagnostics show up your R's?
Yeah.
They do? Okay, good. You're all set. Anyone else whose calculator's R's don't show up, I need to see it. Fix it for you. Oh, it's right here.
And so we do 1.4 on big ideas math?
No, 1.3.
1.2.
Yeah, this is 1.3. I'm behind by a couple days. The assignments are in there and they're showing up, but 1.3 is what we learned. Okay, hang on just a minute. Let me get this for you.
Stop by the office.
Diagnostics, on, done. Okay, the next time you do one of these regressions, the R's will show up. Okay? And the bigger the R, the closer the R is to 1, the tighter the fit, and that's what it's going to be asking. Is it a good fit or bad fit? 0.72 is the break point. Anything above 0.72 is considered a good fit. Anything below it is a poor fit.
And do I need to fill out one of those cards to take this home?
Oh,
I haven't done that.
You don't have you didn't ever check the calculator out with me?
No, I didn't do that on the first
I'll
day.
fill out your card, I just need the number to put down on my rate sheet, what is it?
Um, 47.
What's your name?
Blake.
Okay. Got it.